Welcome to the Handson session on regression. What we are going to see today is a very simple regression model. We will look at predicting miles per gallon of a car based on a number of input parameters. So as you can see, I have imported a couple of packages. Import pandas SPD. This is to read the file and to write the output file. Operating system for setting the current working directory, so I could read my input file. There are three specific packages from scikit-learn. The first one is called as a linear model. From this we are extracting linear regression class. From the metrics package we are importing two separate metrics calculations. One is called R2 score and the other one is mean squared error. Let me execute that. Done. Now I'm changing the working directory using the chdar command. I'm also reading my input file emptycast.csv. The information is stored in a data frame called infile. Done. Now let's have a quick look at the file. As you can see, it's a pandas data frame. There are roughly about 32 rows and there are about 12 columns. The first column is car name. We have miles per gallon, cylinder, displacement, horsepower, ratio, gear to axle ratio, weight of the car, Q-sec, which is basically the number of seconds that it takes to go from 0 to 1/4 of a mile, V engine or straight engine, automatic or manual, gear, carburetor. See, we have about 32 entries. There are no null values, so that's good news. There is one flow object or a character variable, which is carburetor. To give you a little bit more information, let's look at the first few records. So this is explanatory. So you're looking at car name, you're looking at miles per gallon. You can see there are some values like 21. There are cylinders, there's displacement, there's horsepower, so on and so forth. So the hypothesis in this case, if you were to imagine, we want to build a prediction model for miles per gallon of a car based on a combination of many fields. So what we are going to do now, let's assume that we have collected a set of columns as what you are seeing here, and we want to build our first machine learning algorithm using regression. So we are going to use this function linear regression. Now before that, it's a good practice to extract the input and output variables that is required for our model. So we probably may not require all the input columns. We want to select specific columns. So the structure that I'm going to follow is I'm going to create a variable called x, where I'm going to copy just the list of input columns that are going to be useful for my model. To begin with, I'll use just one column and I'm choosing the weight of a car as an indicator. So this will copy the weight column alone from the infile data frame, and it'll create another data frame called x, which will have just that column. I'm going to copy the target variable. Now you might wonder, in both these scenarios, I've copied just one column, but for input, I've used a LOC command, and for the target, I've used directly the name of the column. There is a reason, perhaps a couple of reasons. One, I will be adding more and more columns, so which means this is the structure that will work. And more importantly, the target variable needs to be a pandas series and not a pandas data frame. To explain what I just meant, let me just look at the type of X. It says pandas data frame. and when I do type of Y, it says C. So the input and target has to be in specific formats. Now let's go ahead and initialize the model. The naming convention that I usually follow is lin mod. For instance, lin stands for linear or short form for linear, and MOD stands for an analytical model. Now you are free to follow whichever option that you feel free. Now I'm going to initialize the function. Now this doesn't do anything. It just creates an empty object called lin mod on which we can execute number of commands here. In order to execute the linear regression, the function that we are going to use is fit. Now this takes a couple of parameters, x and y. X is input, y is target. Let's execute that. And it looks like it has executed it completely. Now let's go ahead and look at what it has done. Now linmod.fit essentially has created an analytical model. Now we're not sure what that model comprises of, except that we know that it has created it. Now when we look at linear regression, we are expecting to see intercept and coefficients. Now linear regression is nothing but a mathematical way of representing the relationship between a target variable and a bunch of input. So it takes the format y is equal to a plus b1 x1 plus b2 x2 plus b3 x3. This doesn't have to be uppercase. It changes to a markdown. It takes a format where x1, x2, x3 are input variables and b1, b2, b3 or the slope or coefficients, so which is multiplied with your input variables, and a is the constant or the intercept. Now we need to extract this. Now we have given only one input field, so if I type lin mod dot intercept underscore, I can extract a, essentially intercept, and if I look at lin mod dot coef underscore, I can essentially get the coefficients. So this can be written as my target variable, I'll change this to markdown, miles per gallon equal to 37.285 minus 5.344 into weight. Okay. So what it means is, if you look at the weight of the car, it's currently in tons. So for every ton that you add to the weight of the car, the mileage comes down by about 5.34. So you could see that weight of the car has a negative impact on miles, obviously. So when more the weight of the car, less the mileage. Now, which you probably already knew, but what you didn't know until this equation is, what is the exact impact of the weight of the car? Now this could be used as a reference for the engineers to reduce the weight to maximize the mileage. Now, if you want to go back and create a separate model, maybe with one more input column, I can go ahead and add another column here, run this again, run this, and run this again. Okay. So I added weight as the first column, I have cylinder as the second column. Now you can see that the intercept and your coefficients have changed. So now the equation becomes miles per gallon equal to 39.68 minus 3.19 into weight of the car minus 1.5077 into number of cylinders. Just mark down again. So the equation has changed now. When you are trying to put together two variables, and because it has two separate variables, the coefficients of weight has changed. Now what it says is for every ton that you add, the mileage comes down by about 3.19, and to every cylinder that you add, it comes down by about 1.5. So this is the revised equation. Now you might be wondering, because the interpretation of weight has changed. So normally we don't just stop with one variable, we try with more than one variable, and we evaluate the content of the model, and we ensure that once we have the best model, we then start to interpret the coefficients